Welcome to Khizar School of Advanced Chemistry. October-November 15, 4-2 variant, question number 1, part C. Here is a question regarding the enthalpy cycle. Use the following data to calculate lattice energy of the calcium nitrate solid. You may find it helpful to construct an energy cycle. The given values are hydration enthalpy of the calcium ion, hydration of the nitrate ion, and enthalpy change of solution for the calcium nitrate solid. I am going to draw the solubility cycle. Calcium nitrate solid, when it is dissolved in aqueous medium, it will make calcium 2 positive ion aqueous plus 2 moles of nitrate 1 negative ion aqueous. This reaction, enthalpy of this reaction is basically known as delta H of solution. Right? Now come towards the rest of the things. I have explained in my previous lecture that we need these two ions in the gaseous state. If we have the calcium 2 positive gaseous and 2 mole of nitrate ion gaseous, then from these two gaseous ions we can construct a lattice that is known as calcium nitrate. So when these two gaseous ions will combine, they will make calcium nitrate solid. Enthalpy of this reaction is basically known as lattice energy. Similarly, when calcium gaseous ion is dissolved in water, this is the enthalpy of hydration of calcium 2 positive. When nitrates ion are dissolved in water, similarly this is the enthalpy change of hydration of nitrate 1 negative ion. In this case, we will multiply with 2 because we are going to hydrate 2 mole of nitrate ions. So, come towards the final equation. The equation was delta H of solution is equal to enthalpy of hydration's energies minus all enthalpy of hydration energies minus enthalpy of lattice energy. Now in this case we are going to find the lattice energy. The answer of enthalpy of solution is given, that is minus 19, that is equal to enthalpy of hydration of the calcium, that is equal to minus 1650 plus 2 into enthalpy of nitrate ion minus 314 minus enthalpy of lattice energy. So by the simple calculation we can find the answer of this question, and answer is minus 2259, that is of 3 marks. So there must be a proper and accurate solubility cycle, then equation and the final answer. Okay, now come toward the next question. This is the 4-3 variant, October-November 15, question number 1, part 2. Use the following data to calculate the standard enthalpy change of hydration of chloride ion gaseous. You may find it helpful to construct an energy cycle. Here we have 3 types of enthalpies. Enthalpies of the hydration of magnesium 2 gaseous ion, enthalpy of the lattice energy of MgCl2 magnesium chloride, enthalpy of solution for magnesium chloride solid. So first of all I'm going to draw the enthalpy cycle of MgCl2. MgCl2 solid, when it is allowed to shake with the aqueous medium, there is the formation of Mg2 positive aqueous plus 2 mole of Cl negative aqueous. Now I need these two gaseous ion as well. Magnesium 2 positive gaseous ion, 2 mole of Cl negative gaseous ions. When these gaseous ions are combined to make a solid compound, that is MgCl2, in this case the enthalpy change is known as lattice energy. When these gaseous ions are dissolved in water, then this is called enthalpy of hydration of magnesium 2 positive gaseous. Similarly, this is the 2 mole of enthalpy of hydration of Cl negative ion gaseous. And this one is the first equation that I wrote, enthalpy of solution. That's very much simple. Now the formula of enthalpy of solution is sum of enthalpy of the hydration delta H of hydration in case Mg2 positive gaseous plus 2 moles of delta H of hydration of Cl negative ion minus delta H of lattice energy. So by putting the values we can find the answer of the missing enthalpy. In this case, the enthalpy of magnesium, hydration of the magnesium gaseous ion minus 1925 plus 2 into, let's suppose the enthalpy of hydration of the Cl negative ion gaseous is equal to X minus enthalpy of the lattice energy, that is equal to minus 2524 kilojoules. So, and the enthalpy of solution in this case, that is given minus 155. So we can solve this equation and find the answer of X. In this case, the answer of X is equal to minus 377. Division of the marks will be like if you have the proper expression and correct answer, then you will get 2 marks. Another question, that is May-June 15, variant is 41, and question number 4. Silver sulfate as an example completed the following Hess's energy cycle relating the 3 energies. Basically there are given. One is the lattice energy, enthalpy of solution, and enthalpy of hydration. So once again, these 3 things indicate that this is the basically a question from the solubility cycle. I am going to fill this solubility cycle using these 3 enthalpies. The compound which is given is silver sulfate. This arrow is indicating that there is the formation of Ag2SO4 solid. It could be the enthalpy of the lattice energy. So I can put over here silver 1 positive, 2 mole of silver 1 positive ion gaseous plus 1 mole of sulfate 2 negative ion gaseous. When these 2 gaseous ions will combine together, they will make a solid Ag2SO4, and this is known as enthalpy of lattice energy. Okay. As far as the solubility cycle is concerned, then this compound is solubilized in water. It is added into the water. When it is added into the water, it makes aqueous sign. And this enthalpy is known as enthalpy of solution. The last one, according to the enthalpy cycle for the solubility, we make the gaseous sign into the aqueous sign. This is known as enthalpy of hydration. And the arrow will be from gaseous to the aqueous. That was the question of 4 marks. If you fully understand the enthalpy cycle, then you would be able to solve the question like that.
Thanks for watching.